Hi guys, my name is Heisal Jaison. I am from NTTF Trichy. Today I am going to talk about the module called MPU 6050. It is main use for acceleration and the gyro measuring. So without spending time, we can just check in. So today we are going to talk about uh, our points of focus. What we are going to talk. That's mean by the points of focus. So what is accelerometer and gyro sensor? First of all, before going to directly to the topic, I want to make you sure that you are fully understand about accelerometer and gyroscope or what that means. Then we will check a thorough definition of MPU 6050. Then we will say how it is working, how the sensors are sensing these things and all. Then we will check out the pinout diagrams, what all are the pins are present in these modules. Then we will check at last, or not the last, perks, advantages. Also there will be disadvantages, that's are the drawbacks. So we will check the board in this today's section. And applications, the last one. Applications means in the modules are mainly used in webs. So first of all, we will check what is acceleration and gyro sensors. Accelerometers are the meters which will give the speed, means how much speed the object is traveling. So suppose there is an object, it's in a traveling slow, and sometimes it is going very fast. So what is the speed of that object? It will give us the feedback. Then next one is the gyroscopic sensor. So in gyroscopic, just think it's a x-axis. So this is the object, how much it is turning, or it is in z axis. This is object, how much it is turning. Uh, I think you are clear. How much it is turning. So in accelerometers, it gives millivolt per gravitational force. So each changes, it will give in a millivolt range. And in gyro sensor, it will give millivolt per degree per seconds. So each second it will give each degree, each seconds it will give feedback. So how much millivolt it's set. For example, it's turning upon 5 degrees, it will give 0.5 millivolt or 5 millivolt, etc. Let us assume. Then these are the abbreviations, means millivolt per gravity is MV per G is the millivolt per gravity, and MV per degree per seconds. It's another abbreviation. So before I'll say how it is working. So it's a gyroscopy. The picture you are seeing downside. It is a gyroscope. So if the center spinning, I will say the rotor is continuously spinning, it can get stabilized. So if you are giving an external push or pull, it can be stabilized in the straight degree as its previous form, or it will come back to its previous form. Then this is an accelerometer chip. So it will measure the x, y, z direction, speed, how much speed it is traveling and which direction. So it can give feedback on it. So blessing this two, only this chip was made MPU 6050. So it's both accelerometer and gyroscopic sensor, and also there's a thermal sensor additional to it. Then we will see what is MPU 6050. It's 3-axis accelerometer, and each axis has its own gyroscope. So it's a MEMS system, a MEMS component. So MEMS components expansion is micro ultra mechanical components. So there's a mechanism inside this chip. It's in a micro level integration. So as you can see in this axis, it's a 3-axis means x, y, z in our three-dimensional world, x, y, z. So each axis, it can be taken which direction it is rotating, x minus, x plus, or it's in x-axis it is going clockwise or anti-clockwise. Then we will see how it is working. So inside this, it's a based on capacitors. So it's an accelerometer, how the accelerometers are working. So just think here I will explain. Just a second. Okay. So these are the elastic bands. These sides are elastic bands. So this is the body which will move to and fronts. So if the acceleration happen, inertia. So if a mass is restricted to move, so when the module will start to move, this object will stop to move, which change the capacitance in these two sides. So the ratio between two capacitance are taken to calculate the speed, or how much speed it is traveling. So as you can see, if no acceleration, this two will be same. The capacitance of two sides will be equal. If there is any acceleration, the capacitance of two sides will be different, as you see in second picture. Then we will go about the gyroscope. So in gyroscope, just so in gyroscope, it's like it's working on mechanism only, but somewhat different. I will erase this too. So as you can see in this picture, GIF image is moving to and fro. So it's like a clockwise and anti-clockwise. So same method as I say that inertia. Here also the body limits to move. So the spring tendency will be increased. With that, ship can understand which direction it is rotating. So with that only it is giving it is clockwise or anti-clockwise. Then according to the force or tension only it is saying how much degree or how much fast it is moving. Then we can just check how it is the pinout of this module. So first of all, it's a VCC. Here we can give up 3 to 5 volts. So 3 volts are using node MCU and 5 volt is a standard digital input of a digital system or digital ICs. Then it's next is ground, which is referred to negative terminal of your battery or your supply. Then next is serial clock. Serial clock is the I2C communication. The chip is mainly based on I2C communication. So serial clock and serial data. There will be two wire in the I2C communication. That two wire from microcontroller. Like suppose if your microcontroller is Node MCU or Arduino, from there you want to connect to this SCL and SDA pins. Then it is providing an auxiliary serial data clock and serial clock. So if think suppose you need also a magnetometer. Normally it is used in drones to find an North Pole or South Pole. It is also having an I2C, but just directly we can connect it. So you can just use XDL and XCL. Next one, auxiliary serial data and serial clocks. Then you can select the sensors. If you want to need a motion MPU 6050, you can give a address somewhat like one. It's a data I2C configuration. Here I2C address selection you can see. So there you can give one or zero. If sometimes suppose if it is zero, it will directly connect the MPU 6050 module to your microcontroller, which is Arduino or Node MCU. If you are giving one, it will connect the auxiliary serial clock or auxiliary I2C communications with that microcontroller. So it will act as a like pathway. It's like a shorting it. Then next one is interrupt. So you can provide an interrupt in this because if it is little degree, the microcontroller can be negligible. The degree can be negligible. Or suppose if it is the drone is going, suppose we are taking drone, it is going above 45-degree angle. It should be a severe. The case is severe, so it will give a interrupt to the microcontroller, which will taken very seriously because interrupts are the thing or interrupts are the messages which is sent by a module to the microcontroller that saying that it is important or just look at this the important thing or you will may lead to serious damages. So microcontroller realize it and just try to make it correct. Then we can go about next one is advantages or perks. So first of the advantage is that it is small in size. As I say, MEMS, it's a micro mechanical, electromechanical system. So everything. So in capacitor base, the mechanical system is integrated in the chip. So it's I think it will be in 2 centimeter to 2:3 ratio in centimeter wise. Then low power consumption. The module is working at only 3 to 5 volt. And when just if you are taking a mechanical components case, normally it will consume more energy and all. But in this case, or in this micro mechanical unit or system, it just consume a very less amount comparing to others. So it's less consumption of power. Then high accuracy, so that there will be a limit. There will be a high accuracy in precision. So at the degree, suppose if the degree is between 0 to 45, it can be given 0.5 degrees also. It can be given accuracy. Then high repeatability means if you are checking it again means you are taking it and checking in the same place. It's in a standing position. It can be given same output. That means that is the meaning of high repeatability. Then high shock tolerance. When you are measuring an accelerometer, if as I say capacitor, it's a mechanical thing. So if any shock is also acted to that module, we can also measure as acceleration. So that also can be tolerance. So if it's a small shock or a high shock, it means we are shooting it. Also, it can be tolerance. It means it can understand what is the movement, linear movement, and what is a shock. Then we will go to drawbacks. As I said, this module is a low cost, cheap, and commonly used. There will be some drawbacks also. It's sensitive to the external interference. Sensitive to external interference is that means if you are take suppose the case of drone, um, or I will say about phones. In phones, sometimes if we are keeping it in horizontal mode, sometimes it will not get it. Means the phone is horizontal or parallel. So there will be some bugs and all. Then limited accuracy. So if I will say this, it will be up to 90 degree plus or minus plus 90 minus 90, it will be very accurate. Then after that there will be some tolerance, means plus or minus 2 or 3, it will be increased by the angle of degree of turning increases. Then calibration challenges. First of all, when we are installing this thing, there will be calibrating. So sometimes the calibration can be mistaken very fastly. Then limited communication options. So in this IC particularly, this module MPU 6050, it is having only I2C communication. So you can just interface this IC with I2C communications. Then last but not least, we are just going to the applications. So this IC mainly uses in robotics. So if you are in robotics or you are studying in robotics, for weekend project you can use this IC mainly. Then we are at air. So if you are keeping a glass, when you are looking down, the video also looking down. So it's there also you are using this IC. It's like a gyro sensor or up accelerometers. Then drone stabilization. It is commonly, or the we will say the function of MPU 6050 is that to use in drone or stabilizing the drone. Then gaming. So if DIY game shoot the gloves. So if you are shooting it, the game also will shoot. So the motions of the gloves are measured by the same ICs or the same modules. So before converting, it's having a microcontroller or microprocessor to convert this analog. Means from the IC you will get the analog output. So this analog output is converted to digital and transferred by I2C communication. So there is a ADC, analog to digital converter, and from ADC it is compressed to I2C using a processor or microcontroller, which can be which can store data, and when we are getting, you can obtain from it. So it's having a onboard microprocessor or microcontroller, which is for converting this data into I2C configuration. We can program that IC. So I just give an extra detail or extra idea. So thank you all. I hope you all understand my short talk or my topic. Thank you.